later on my colleague Rob Rikke is right there. He'll take over from we're recognizable by our suits. If we're wearing a suit today, you can call us Rob. It's really easy for today. Normally during communication it makes things a bit difficult actually, which is why I usually go by the name Billy and Rikke. But for tonight, for you guys at least. Gonna keep it simple. Just yell Rob and someone will come running towards you. So my name is Rob Moleman, also known as Billy. I'm a 4th-year industrial design student. This is where I grew up actually, on the house built here. About a year ago, I told my parents, hey, I want to do WASUB full-time. And they responded, what the hell is WASUB? And I told them, WASUB is a dream team. Dream team are an innovation at TU Delft or an experiment by the TU Delft. There's some pretty famous ones like Luna, Solarboat, and Hauptee. There's also some idiots building a human-powered submarine. And then their response is, oh, what's a human-powered submarine? Because I've never heard of that before. Neither did I before I heard of WASUB. A human-powered submarine is when you take a boat, like this, you make an open boat, you push it on the water, you fill it with water, you put in a pilot, and you first try to find someone who's actually crazy enough to go in there. Luckily, we succeeded again this year. And you submerge it, you put him in there with a diving gear. He has his diving gear under him, so below his belly. He makes his feet into the pedals, start pedaling as fast as he can to get this. To which they respond, oh, yeah, that's pretty cool, but why? That's also a very good question. And the main reason for that being is this. It's a real nice stock image. We as a foundation provide this for our members to learn. That includes me and Rikke, but also all the 24 part-timers. You come here in your team, you know nothing. You know nothing about boats, but you also know nothing about running a team, doing your own finances, public relationship and everything. And the idea is that at the end of the year, you at least know something about them. As a finishing touch to this, we do participate in races with our boats, so they're not just for show, they actually have to perform at some point. There's races in America, where a tow tank of a kilometer long, where you take a 100-meter sprint. That's also what the team previous year did. And then there's also a much more fun race in England, where you have to do some small course. That's what we'll be doing this year. More about it later. So that's the end goal of this year. WASUB itself has already been going for quite some time. We're currently on the 8th iteration, so the 18th, meaning there's already been 7 boats built before us. There are people that now know more than we do, but when they started, they knew nothing as well. So it shows it's actually possible to do this within a year. So it started in 2004. It's quite a long time ago already, as a bachelor thesis for the aerospace engineers. And they learned that there was a competition actually for submarines, human-powered submarines, and eventually decided to join. And in this there was some small break, and eventually it started back up again. And some big highlight to note is the WASUB 5, 3 years ago by now already. They still hold the world speed record for single-person propeller-driven human submarines. Yeah, it's quite a mouthful, but it actually still holds up at 7.42 knots. For those that don't know yet know what a knot is, that's about 13 kilometers per hour, twice as fast as an Olympic swimmer. It's pretty fast. 2 years ago, our direct predecessors, WASUB 6, also competed in England. They also made a propeller-driven boat, which also did extremely well, especially on speed. And now led in competition by reaching speed twice as fast as the second fastest boat that year. And just last year, we had WASUB 7, for the first time in WASUB's history, participated in an alternatively driven boat, where they got second that year, which is an extremely big achievement considering we never done this before, and actually made a functioning boat, which is already a challenge each year. So this year is once again a completely new team of 25 students from the TU Delft, the Applied Sciences, Haagse Applied Sciences, and the VU Amsterdam. And with this team we'll be building, or designing, building, testing, and eventually racing our own boat, the WASUB 8. So that starts with the design phase. We've now finally rounded it up after half a year of hard work. We're finally able to show you what we've done up until now. Luckily, you don't have to smell in these places. I've been told it's very bad. Luckily, I can't smell either. And we're actually starting to roll into production. So we've already have some of our first part produced, which is really cool to see. Finally, after a 2.5 years and looking at tired and frustrated engineers, and like, hey, we have some stuff to show now. Soon we'll move into testing. This is actually a test we did with Very, very cold water. It was about 3 weeks ago. The water was at roughly 4 degrees, which as a team manager was very happy that I can tell other people to go in, which is why I'm standing there on the side and not wearing a diving suit. And eventually, and next to all that, of course, we do some events, we do our own publishing. We've been at Europort again this year. We had the amazing fun to be at Science for Humanity, where we actually had our own dive tank, thanks to the DMO, which is not only really cool and a nice way to show you off your boat, but also our first actual option to test the boat in more open waters in a safe and controlled environment. So, as I said, we do this as an education platform, so we teach our members not only all the logistics and everything that comes from the team and design, we try to teach as many of them that actually want to, how to dive as well. Makes it handy for the testing, and apparently it's extremely fun to do, which is a nice benefit, of course. So eventually we have a team of 25 people. That's a living nightmare to manage, especially when you consider that 24 of those 25 people, not 24, 23 of those 25 people are part-time, so not constantly available, meaning also it's very difficult to get set deadlines on when people are and are not working. And for that reason, we divided the team in different departments. So eventually we have 7 different departments, 5 technical ones. You'll also hear them pass by during the actual design part of the presentation. We have a management and we have a PR department. And eventually this is what it's all about. You see WASUB 6 all the way in the back with the Dutch flag. This photo was taken 2 years ago. This is in the Kinetic Basin in Gosport, England, where the actual race will take place from the 3rd till the 12th of July. And for the actual race, we have to do a small parkour, so not just going straight, we actually have to steer. We have about 50 meters before you get some timing gates. This timing gates determine your top speed for that run, and you get a big U-turn where you eventually finish with the most challenging part of your run, the slalom, where you have to be both fast and flexible. So being able to control your boat is a major challenge and extremely difficult to do, I've been told. And that leads us to the goal of this year. Our goal this year is to win this competition, of course, to win a specific part of this competition. So we want to win the European International Submarine Races Trophy in Gosport, England on the 12th of July. And that's quite a mouthful. What does it actually mean? Okay, so the EISR Trophy is also known as the overall competition. It's not just being the fastest, as we've already proven we can very well be the boss. That's actually only 48% of your total points. So 48 of your race performance totals 48% of the points you can make. So actually extremely important as well is that you have a good design, a good foundation for your design, and also very good at explaining why your design is the best. Kind of for another, about a quarter of your points. And you also get to the little stuff somewhat, your production. How much does your actual boat come over and is the same as your design? What are the major differences? Are there actual differences in there? And then you get also how reliable is your boat? How many runs did you finish? How many runs did you crash? That eventually tallies up to the score as well. And there's also the little aspect of safety, mostly because the race people doesn't like our pilots dying. We don't either, they're very rare breed. So you get some points for that as well. And with that said, and our year goal now determined, Reke will now explain how we will achieve this goal.
So, you guys know what we're going to do, but you don't know how we're going to do, and I'm going to tell you today. Our design, to start off, we looked at our predecessors, especially WASUB 6, they did the exact same competition, and yeah, we learned from them, since we don't start from scratch with the A team, we have a lot of experience before us. So, the goal, the trophy, look at the percentage, what do we need to build to obtain as high amount of points as possible. Well, race performance, it's simple. Just build the fastest boat and you're there. Designing and production, we're engineers from the TU Delft. This is what we study, this is what we do. Reliability, this is where we also looked at WASUB 6. WASUB 6 was not able to get the full points there. That's why they didn't obtain this overall trophy. How are we going to do this? Well, there are a lot of problems with keeping stable at high velocities, and that's one of our major spear points this year. As safety, as said before, we don't want our pilots to die, and it's not going to happen, I assure you, this year. So, design philosophy, build the fastest boat, let it finish every run, so complete control to pass the finish line as expected. But also we wanted high repairability. Why do we want high repairability? Well, in the unlikely event something breaks, you want to repair it overnight, and the next day you want a completely functioning boat again. So that's why we put it on there. This is our design, and for the people who paid attention, it looks an awful lot like WASUB 6. That's because they did great, but we're doing better. We're gonna do better. We like beauty; it's always on the inside, and I will show you now. This is our hull. It will be 3D printed this year. This hull is only a hydrodynamic shell. That's the only purpose it's gonna function this year, but it's good at it. It has a low drag and is proven in the previous years. So why 3D printing? Well, we don't have to drill any holes. We can make a design, make it perfectly, so each and every part is perfectly set on the hull with a 90-degree angle, no offsets. This will make the boat more stable. Well, where do we put our parts on then if it's only a hydrodynamic shell? We have an internal frame. Each and every part will be mounted on this frame, which results is we have a working boat even if the shell isn't on it. So we can repair the boat, just put the shell off, have a look at it. We don't have to crawl into cramped spaces like previous year. It's going to be a blast. So, as seen, we're going to make a propeller-driven boat. We're not going to follow the trend from WASUB 7. And WASUB 6, they had speed. They got the maximum points for being the fastest. So why change a winning team? This is the exact same design, but it works. It's proven itself. What is it? It's a counter-rotating propeller. This will, you have one propeller turning the one way and one propeller turning the other way. This motion will counteract each other, making the boat very stable. Now, this propeller needs to be connected somehow to our pilots. How we're going to do this is shown here. Let's start at the pedals, since everyone knows where those are. I think everyone can recognize them. You see they're gliding in the red box. Here our bevel gear is located. That's one of the most efficient way to transfer your power. That's why we're going for this bevel gear. Then you see in orange, you see a carding shaft. This shaft has two universal joints and is telescopic. This enables us to move the red box to the exact position the pilot can have his optimum power, so we can position it so that the pilot can do his work the best. Then you see the blue box. Until now we only have a single turning motion. This is a coaxial, and this will make the motion into two directions. So putting this all together, this is how we're going to go fast. But as I said, we want to do the parkour, we want to be stable, so there's more. Let's first, for the non-engineers here, explain three terms. That's all I'm going to explain, and that's all what's needed. You have the pitch motion, it's going up and down. You have the yaw motion, it's going left and right. And you have the roll, which is on its own axis, which will result that if you're going to roll, the pilot will be upside down. So why do we need these definitions? I want to explain how we're going to steer. This is our back of the submarine. Here you see how we're going to be able to steer. You see the large yellow part. It's for the vertical fins, and it's going to make the boat make the yaw motion going left and right. This is going to be a manual steering system, which is proven to be worked in the 6. We have a pilot that has experience with the 6, so this makes it a very strong combination to perform on the race with a pilot who has experience with the steering system and a proven system. Then you see the red box. Those are servo motors, which will electrically control the horizontal fins. These horizontal fins will make the pitch motion, so going up and down, and also the roll motion. So, We're also gonna do data acquisition this year. At the start of this year, we found out that not a lot of parameters are known during our flight, so to say. So we want to know the velocity of the submarine. We want to know how fast we're actually going, and we want to know the RPM of the pilot. This knowing how much RPM the pilot can actually perform during the test, during sailing. We can use this next year or even further to optimize the gear ratio so that we know how much RPM runs per minute the pilot is going to cycle. Then we can optimize our propeller for this. And we want to know the full position and motion of our submarine. We're going to do this with an XSense, and with this data, we know the exact position and motion during the whole flight. So then we have a motor that's electrically driven for the fins. We have the sensors. Then it's only a small leap to make an automatic stabilizing system. It will, as I said, the yaw motion, the pilot, it's manually, but the roll and pitch will be fully controlled by this automatic stabilizing system. This is also done previous years, tried at least, and with this obtained knowledge, we're on a great way to actually achieve it this year. So, what is WASUB? WASUB has a proven propeller to go fast. It's a more efficient drivetrain. It has force feedback for the pilot to make the steering actually nice and possible, and automatic stabilizing so that the pilot only has to turn left or right. And with this, we're going to win the ISR trophy. Thank you.
We need more than just a good boat to actually win coming July. So I'd like everyone from WASUB 8 to step forward, take your moment in the limelight before you actually have to go back to building this really. So please, WASUB 8, don't be shy.